So we need a way to know if a missile collides with something. If a missile collides with something, then that missile needs to destroy itself and possibly destroy whatever it collides with. So let's add a new system. Let's call it a class. Missile contact system. Component system. Now we're actually going to get a game going here. So far, we're just moving objects in the world, but now we're going to have some contact in the world here. So, what does this do? What does a missile contact system do? And this actually is going to be a slightly more complex system, maybe the most complex system that we're going to have to write, because normally in a system, you have a query. You're going to do an entities for each for a query. But this is, I need two queries here. I want to find all missiles, and then I want to find all team items, right? All aliens, all players, all motherships, anything that basically belongs to a team. And I want to find those two, and I want to see when does a missile overlap any of those things. So we're going to have to iterate through them all and see when do they overlap. And when they do overlap, we can then decide, do we want to destroy them or not? So this is going to be the most complex of our systems. So to make this work, essentially we're going to have two queries. So not in our update, sorry. Let's create a team query. Entity query. Team query. Let's override our onCreate and build this query. So this.team query. Get an entity query, right? Component type of read-only, team data, and a component type of local to world. So I'm not using translation here. I'm using the local to world, which is its world position, right? I want to get the world position of all of these items, of every item that belongs to a team, so that I can compare it to the world position of a rocket or a missile. So this is not translation anymore. I'm now looking at its local to world, which will give us the world position as it's been rotated, as it's been scaled, after all that gets applied. So this will give us a query. I got to get a bunch of arrays now. We're going to have to get some arrays to make all this work. So the first thing I want to do, and we're going to start using a native array. You're going to use these a lot in ECS. You're going to use them a lot, and I'll explain them. This works just like a normal .NET C# array, except that it's a structure, not a class. Arrays are classes. They're heap memory. They're objects instead of structs. They're references, right, instead of values. A native array is a struct. You can see up here it's a struct, which means it's a value type, not a reference type. And that's important because you can then use arrays in the entity component system because it's a structure. And I want to get a list. I want to get an array of all entities that meet our query, right? So I want to say team query, and then we can execute this query to an entity array. And you notice here it's asking me for an allocator. An allocator is a couple of options. And you got to decide how long do you want this array to last, because these arrays are supposed to be short-lived. They can live on the stack. They can live on the heap. They can get reused. They can get shared. You want to make sure the lifetime of this array is set correctly so that you can hint to the ECS system to be optimized. For the most part, you're going to be doing temp job. Most of your ECS systems, when you're creating these arrays, are probably going to be temp job. A few might be persistent. Persistent means they're going to live for a long time and you'll delete them at some point late in the future. Temp job means they should live for just the execution of the job. Basically, the lifetime of on update is how long temp job is. And that's what you're mostly going to use. Temp means you're going to use it and delete it within the single frame. So not in and on update. So temp can be used, but less frequently. The other ones you're probably not going to use as often. So I'm not going to explain them. So for our need here, it's a job based, right? So I want to use the temp job allocator. Now, because this is allocated, we have to make sure that we are disposing them. You have to dispose these. If you don't, Unity will throw errors and say, hey, you forgot to dispose this. They have to be disposed. And they have to be disposed at the right time. If it's a temp job and you don't dispose it at the end of the job, it will warn you in the editor. Let's create another array of team data. This is teams, team query. And this is 2-component data array of team data, allocator, temp job as well. So why are we doing this? This is the same query. We're kind of executing it twice, essentially. Not really, it's executing once, but we're calling it twice, and we're getting 2 different arrays out of it. Well, that's because this query gives me 2 different pieces of data. I want to know what is and we're actually going to call it again, because remember, we have 2 component types. These are all independent components, and this is how you access these components off of a native query like this. Now, the indexing into these arrays, these native arrays, is going to be the same for everything, for all of them, right? So, and I'll explain that when we get into our actual implementation here. It's also an allocator temp job. Oops. Let's make sure these are getting disposed. So teams.dispose, positions, dispose. So make sure we're cleaning up, and we'll add some code here. So we are getting 3 arrays. So index 0 of all 3 arrays, basically we can vertically slice through all the arrays. So index 0 will align together. So index 0 of this array will pull back an entity. The index 0 of team data will be the team data for that same entity, and the local to world will be that data. So index 0 across all these arrays is for the same entity and its components. Index 1 is another entity and its components. So that's essentially how you can get the entity, and then you can find its components for that entity in an efficient manner. We could in a slow manner call the entity manager, but right here we're actually going to know that since we have to do a lot of loop iteration, we're going to do an iteration in an iteration, or a loop in a loop. That's already going to be kind of slow. So we want to optimize a little bit if we can up front. And this is going to allow us to optimize up front. This is another pattern that you're probably going to use in a few cases, not in every case, but in a few cases. And it's going to make sense when I use it. So now let's have our entities for each. This is going to be a second query, essentially. And this is going to be the query for missiles, right? Let's get missile data. Let's get its position. Let's get the local to world position. So here's our for each, and then remember, after this for each, we're disposing everything. We can access these arrays inside this for each very efficiently. But so now I have a missile. What we're trying to do is for every missile, iterate through every missile. For every missile, check if the missile collides with anything, right? See if it overlaps with anything here. And if it does, we'll execute some code to decide what to do. So to make that happen, we have to iterate through all of the teams, or all of the entities, all of the links. All 3 of these links will be exactly the same because they all are in the right order and they're all aligned. So you can use whatever you want there. Let's grab the entity. Let's see, the team entity is equal to entities of I. If we are referencing ourselves, because it is possible a missile is part of a team, is equal to team entity. We don't want to do anything here. Otherwise, we would instantly blow ourselves up or something like that. We don't want to check against ourselves. Just a small little optimization. Let's go grab the team for the entity that we're checking, right? Teams of I. And then now let's go do a distance check as well. So I want to get float 3 of team position is equal to positions of I of position. Because this is now more like a transform object. This has position. This has rotation. This has what's your forward vector, what's your up vector. It has that data. I just want to get the translated position. So we have our position. We have the data we care about. And let's get our distance out. Let's do a distance check, right? So let's do distance. The new math library has a distance function that you can call. And we want to pass in our position, dot position, right? This is the missile position. And use the team position, right? What are we checking against? If distance is, let's say if they're closer than 0.3, which gives it a little bit of a radius around the missile, a little bit of a radius around the missile. If that happens, that means we have collided. What we want to make sure happens no matter what, if our missile collides with something that is on a team, no matter the team, first things first, let's destroy the missile. Missile's going to go away. Now let's actually do a missile check. We know missile data has the team that it belongs to. If it's not the same team that it's colliding with, right? If it's colliding with something of the other team, then let's also destroy what we collided with, the team entity. So we don't have hit points, right? We don't have a strength or shields or anything like that. Essentially, if a missile hits something of the opposite team, we want to make sure that we destroy we destroy what we're colliding with, and then no matter what, the missile itself will also collide. And that's it. I know this is probably one of the more complicated systems we've written, but this is still not that complicated. We are iterating through every object in the game that has a team. If it's ourselves, then ignore. We do a distance check to it. If it's close enough, we check what team they're on. And if it's on the opposite team, destroy it. And then also make sure we always destroy the missile. That's simple. That's basically Space Invaders. We're not doing any score checking here. We're not doing any type of counting of like how many enemies have we destroyed, anything like that. If the alien hits us and destroys us, we also destroy our entity, the player entity. We'll have to check for that. But that's it. So theoretically, we should be able to fire a missile at one of these motherships, and it should work. I got to go fix something on a player missile first, though. A player missile needs team data. What team does this belong to, right? And we have missile data has also. This is independent of the team that it's on. I know it's the same data here, but that's because every object in our game that can collide needs a team data structure. So now let's hit play and let's see what can happen here. Give me a moment. Okay, let's see if I can actually hit things. Apparently I can't hit things. There we go. And I'm really bad at Space Invaders, if you guys haven't figured out. Our rockets fire a little slow. I wonder if we should increase the speed of our rockets. And wow, so embarrassed right now. Okay, there we go. There we go. Boop. Also, our radius is kind of small. I'm not doing like a bounds check. This is not like a box collider system. We kind of have a radius for a rocket, and I might want to go increase that radius for the rocket. It is a little small. For demonstration purposes, though, we're okay. But you can see that we are able to destroy ships when rockets collide with them. Let's actually do that. Let's go to our player missile code, and we'll just increase it a little bit. For our distance check, let's go 0.5. We'll almost double it. Okay, so that is our missile collision system, and this will, if it collides with whatever, it's gonna work. So now when we add aliens, they'll also work.